Wait no longer. Here's 8.3 part 2. Oh yeah, oh yeah. Okay, this is kind of like the same thing as the part 1, because we're still looking for discontinuity. I'm not saying that word right, but you get what I'm saying. Holes or asymptotes. So basically you're looking at this, and you have to realize when is it a hole and when is it an asymptote. So looking at this first one, here again it's always your, what am I doing? Look at this first one, it's always going to be your in your denominator. So I have x cannot equal 2, positive 2, x cannot equal a positive 3. Both of these would be vertical asymptotes. Vertical asymptotes at both of those spots because of the fact you're not actually canceling anyone out. So I want you to try to do b by yourself. Looking at 2, x cannot equal positive 2. X cannot equal a negative 3. However, this time, I can simplify that fraction now after I have that. These two cancel each other out. So I'm just left with 1 over x plus 3. So with my domain restrictions, this x cannot equal 2 becomes a whole. And this x cannot equal negative 3 becomes a vertical asymptote. So you will have to do that when you're graphing. So I want you to do D by yourself. When I'm looking at horizontal asymptotes here, horizontal, remember those are going to be your y equals. And you're always looking at your numerator, the m, so m will be on top, n is on bottom, but we're actually looking at the degree of the function. So my degree, always the degree. So this first one, this is saying if the top degree is smaller than the bottom degree, then it's always going to be y equals 0. If the top degree is larger than the smaller degree, the denominator degree, then there's no horizontal asymptote. If the degrees are the exact same, then the numbers in front of that leading coefficient will be your asymptote. So I'm looking at this first one. Here's my two leading coefficients. When I'm looking at my x's, they're both a degree of 1 because this is the first power and this is the first power. They're equal. So now this is where if the degree is the same, the horizontal asymptote will be the number in front. So my horizontal asymptote would be y is equal to 2. Next one. Again, here are my two leading coefficients, and right now the bottom degree, because that has a degree of 2, the top has a degree of 1, the bottom degree is larger. When the bottom degree is larger, you have a horizontal asymptote at y is equal to 0. Bottom larger, y is equal to 0. And on the next page, here are my two leading coefficients. My degree on top is 2, degree on bottom is 1. If the top is larger, there is no horizontal asymptote. No horizontal asymptote. So I want you to try D, E, and F by yourself. No. So now we're getting to the actual graphing part. So first thing that you want to do when you're graphing is to factor. So on top, two numbers that multiply to get negative 12, but add together to get a positive 1 would be positive 4 and negative 3. On bottom, two numbers that multiply to get positive or negative 4, add to get negative, or just 0, would be positive 2, negative 2. Now you want to look at your asymptotes. So first when I'm looking at my vertical asymptotes, and I know I'm going to have vertical asymptotes because I can't cancel out anything here. There's nothing that can cancel. There'll be an asymptote x equals a positive 2 for this right here. There'll be another vertical asymptote at x equals negative 2 because of this right here. Horizontal asymptote. If I look back to this right here, looking at my degree of my leading coefficients, they're the same. So that'd be like 1 over 1. So y would be equal to 1, my horizontal asymptote. So if I plot those in my graph, vertical, up and down, so at positive 2, at negative 2, at y is 1. You don't have to make those swishy noises, but you might want to. So now when you look at this, there are 1, 2, 3, 4, 5, 6 different places where the graph could be. This is where you want to make sure to use your graphing calculator and make a table so that you know where the shape is and how does it look like. So you might be thinking, where do I even start? Well, I'm going to make 3 different charts because technically I have 3 different areas where the graph could be. I have asymptote at x equals -2, so I'm going to look at numbers on the left side of -2. Now, you're not always going to have the perfect number, so I'm going to put -9. And again, I'm looking at my graphing calculator right now. That's about 0.8. -4 has a nice number at 0, and -3 at -1.2. Then I have a section in between -2 and 2. So I have -1 and 4, 0, 3. Again, this is just on my graphing calculator. When you're putting this in your calculator, you should make sure to have parentheses around the top and around the bottom. 3 and 1/3. And then I have points on the right side of 2. So I have 3 and 0, and 4 and 2/3. Now you want to plot those points. And that's what your graph should look like. And then you can always push the graph button to make sure that your sections or your branches or the different sections look like what you drew. Try to be by yourself. If nothing else, you should be factoring, seeing if you have holes or vertical asymptotes or horizontal asymptotes. And you have a wonderful day.